Today we're going to look at the difference between exponential functions and logarithmic functions. So we're going to start first by looking at the exponential function here that is graphed. The graphed equation is y equals 4 times 1/3 to the power of x minus 1. We're going to talk about some terms that we're familiar with first and then get to some kind of newer terms that we've been learning. Here we go. The x-intercept, like we always have known, is when my graph touches the x-axis. That is going to be at that point 1.262, 0. Our y-intercept, same thing, but when it touches the y-axis now. So that would be at the point 0, 3. If it didn't intercept or touch, we would put none. Our asymptote's one of the new terms we've been learning. It basically means when my graph hits a brick wall or cannot go past that. For instance, if we look at my graph over here, it starts to flatline down here. It's not going to go past this line. How do I know? Because exponentials have horizontal asymptotes where they cannot go past. They kind of decrease rapidly, and then once they get to that line, they're kind of slowly decreasing, almost getting to that -1, but not quite. How do I tell what my line is? Well, I'm using this point y equals -1. It's y equals -1 because my graph is at the point -1 on the y-axis. It's horizontal, so that's why we talk about y equals. Now we're going to look at domain and range. So domain, we look left to right. Well, all the way on the left side of my graph, it's going, and it's going to keep going towards those negative numbers, so negative infinity. When I look at the right side of my graph, it's going to keep going all the way right to my positive infinity. Also, to help you out, domain for our exponential functions is always negative infinity to positive infinity, aka all real numbers. That's always the case to help you remember. For the range, we're looking bottom to top. So the bottom of my graph starts at that asymptote of -1. Does not go past that. Gets close to it, but will flatline and get really close, but not past it. What happens at the top of my graph is it's going to keep climbing up. It's going to go past my y value of 10 way up to infinity. So how I can help with the range is use that -1 from our asymptote. The end behavior, again, is a new kind of thing. It's talking about the ends of my graph. So over here, at this arrow end, the left side of my graph, I'm going to be approaching negative infinity. So as x approaches negative infinity, what's happening to my graph? Well, it's going up to the sky. It's going way past those y value of 10, 11, 12 to infinity. So as x approaches or goes to, we use an arrow to show approaches or goes to, because that's what it really is. It's moving towards that. So as x approaches negative infinity, y will approach positive infinity. Now let's talk about when x approaches positive infinity. So as I go over here to the right side of my graph, it's going past 10 way to infinity, but what's happening with those y values? Well, it's getting really close, but not touching that y of -1. So we'll put an arrow that it's going towards, but not hitting y -1. So again, how you read that is as x approaches negative infinity, y approaches positive infinity. That's what the arrow stands for approaches. Then same thing, as x approaches positive infinity, y approaches -1. So we just finished looking at our exponential function. Now we're going to go to our logarithmic function. One big difference to tell between the two is our exponential function has a horizontal asymptote. Means the brick wall, the place where the graph does not go past, is horizontal in its shape and graph. As you see, kind of just looking at the graph, what we could say is it's decreasing rapidly, and then it decreases ever so slightly at a very slow pace till it never reaches that -1, gets really close to it. So that's what we're looking at for asymptotes. We're looking for that slow decline or increase, almost looking like a flat line there. So for our logarithmic function, specifically this one, when we talk about having a vertical asymptote, means the graph does not go past, it hits a brick wall way over here, vertically in nature, up and down, looking at that -3. It looks really close to that line, and if we zoomed in, we would see it's not on that line. But if we looked really closely, it would go as close as it can, but never touch that -3. But it will slowly increase away from that -3, and then increase ever so slightly more, kind of a steeper increase over here on the right. So anyways, let's go ahead and look at our logarithmic function here. Our function here is y equals log with base 2, parentheses x plus 3, and parentheses minus 2. So let's go ahead and look at our x and y intercept. So x-intercept, again, we talked about is when it touches the x-axis. Well, that's going to be our 1, 0. Super easy when it hits that x-axis. Now we're going to look up and down at our y-axis, and it hits it at this point of 0, -0.415. Super easy to kind of find our x and y intercepts. So again, the asymptote's a little bit harder, but it is the point where the graph hits a brick wall or does not go past. So our graph is going to be going, but it kind of stops. It will never reach, slowly approaches, but never reaches this x minus 3. So our vertical asymptote is going to be x minus 3. Again, it's going to be x because that's the x value it's hitting here. It's not hitting a y value, it's hitting that x value of -3 on our graph. When we talk about the domain of log functions, it's not going to be all real numbers like our exponential functions. It's going to be from our asymptote of -3 all the way to positive infinity. Because if I see over here, the left side of my graph goes so close but does not touch that -3, then my right side of the graph will go past x equals 10, way past to infinity. For the range, though, it is going to be -infinity to infinity, all real numbers, anytime you have a log function. So that's another difference too. The range, as you see down here at the edge of our graph, is going way past that -10 to -infinity on the y when we look at the bottom of our graph. And then when we look at the top of our graph, this top point over here, it is going to be approaching slowly but surely positive infinity on the y. Last but not least, let's talk about end behaviors. The end behavior is looking at the left and right of my graph, kind of where it's going. So over here on the left, as you see, we are approaching this asymptote of -3. So as x approaches -3, remember it's not going to go past that. That's our brick wall. Our kind of line the graph does not go past. And when that is happening, what is happening to our y values is they're going way down. So they're going past -5, -6, all the way to -infinity. So you're just really, when you're doing these end behaviors, you're just really describing where your graph is going at each end. So when I look over here at the right, so this part of my graph over here on this end, my x is going past 10 all the way to infinity. So as x approaches infinity, what's happening to my y values is they're slowly increasing all the way up to positive infinity because it is an arrow on the edge of our graphs. Thank you for watching this video and have a wonderful day.